Okay, I'm going to do some parallel circuit practice problems. I did a couple of these in class, so I'm going to do different ones than the ones I did in class. So this is the same sheet I gave y'all in class. So let's do this one, and then this one. And if I have time, I might do this one. I might do 2 videos. We'll just see. So, quick recap on our rules for parallel circuits, okay? So we're always using Ohm's law, voltage equals current times resistance. For parallel circuits, my total voltage equals my battery voltage, and then that is the same for each component. So my voltage for this branch is the same as this branch, is the same as my total. My current adds up. So I have a total current that's equal to the current in each of my branches. So like here, this is branch 1, it's got a current value. This is branch 2, it's got a current value. To get my total, I'm going to add those up. And then my resistance is my 1 over R total equals 1 over R1 plus 1 over R2. That's because my total resistance is decreased every time I add a resistor with parallel, because you got multiple pathways. So remember the traffic analogy, okay? Okay, so let's try this first one. We're going to write our givens down first. So we are given a total voltage from the battery of 40 volts. We're given a resistor 1 value of 5 ohms and a resistor 2 value of 20 ohms. Okay. So we're going to look at our rules. We see that for parallel circuits, voltage is all equal. So my voltage for each of my branches is going to be the same as my total for my battery. So I can put 40 and 40 here. Then I see that I've got voltage and resistance for each of these lines, so I can use Ohm's law here. I'm just going to take, remember your triangle. Okay, so if I've got voltage and I've got resistance and I need current, I'm going to divide voltage by resistance. So I'm going to divide 40 by 5. That's going to give me 8 here. I'm going to divide 40 by 20. That's going to give me 2. And then looking back to my rules, I add my currents up. So I've got a branch here that's 8 amps. I've got a branch here that's 2 amps. Those are going to add up to 10 amps. And then the last thing is my total resistance. I can either use this equation, or because I've got voltage and current, I could use Ohm's law. I would divide voltage by current, and I would get 4 here. Okay, and that's my total resistance of my circuit, which is lower than my individual components, which is what I expect to see. Now I can try that also with 1 over R total. So I'm going to do that for you here just so you can see it done. We had our first resistor was 5, so I've got 1 over 5 plus 1 over 20. So remember, this is 1 over R1 plus 1 over R2. Okay. Like I said today in class, I don't really like fractions. I don't want to try and simplify those and leave them in fraction form. So I'm going to, I'm going to divide 1 by 5. That gives me 0.2. And then I'm going to divide 1 by 20. That gives me 0.05. I'm going to add those two up. 0.2 plus 0.05 gives me 0.25. And that's equal to 1 over R total. That's not my total resistance. I have to now take this and do like a crisscross kind of thing or a flip kind of thing. Whatever I do in the end, I'm going to have R total equals 1 over 0.25. And that should give me 4, which was what I got on the previous page. So we'll see. Whoops, that's wrong. 1 divided by 0.25 gives me 4. That's the same as what I got right here. Okay, so like I said, if you don't have to use it, don't. But if you do need to use it, that's how you do it. And the most important part is to remember that last step of flipping this, because if you leave it the way it is, then you're not going to get the right answer and you're not getting our total. You're getting 1 over our total. Okay. Okay, let's do another one. This one, we're given a current. That's going to be the current for this branch number 1. So I'm going to put that here under branch 1. We're also given a resistance for branch 1, 6 ohms, and a resistance for branch 2 is 12 ohms. Okay. So looking at my givens, I see that I've got a line where I have current and resistance. That means I can use Ohm's law here, and I can multiply those two together. So I'm going to get 3 times 6 is 18. Again, looking back at my rules, all my voltages are going to be the same for a parallel circuit, so I can fill in those two other values. I can get current for this line because I see I've got a voltage and a resistance. So I'm going to divide 18 by 12. Gives me 1.5. I can add my currents up because that's another one of my rules. My currents add. I get 4.5. And then that leaves me with my total resistance. Again, I can use Ohm's law. I don't have to use that other equation. So I would do 18 divided by 4.5 there. Again, for 4, weird, because I am dividing voltage by current. Again, this value is less than these two. So let's double check that real quick, and then we'll wrap up this video. Let's say 1 over R total equals 1 over 6 plus 1 over 12. I think that's right. Let's see. Yep, 6 and 12. I'm going to get rid of the fractions because I don't like them. So I got 0.167 plus 1 divided by 12 is 0.083 forever. 167 plus 0.083 is 0.25. And that's, again, not my final answer. That is 1 over the final answer that I want. And so I'm going to do a crisscross or a flip. I end up with 1 over 0.25 equals R total. And again, that's going to give me 4. That's just coincidence. Okay. So that's my kind of double check on this number. But I didn't need to use that equation. I was able to use Ohm's law and my rules for my voltage and my current to fill all my values in. So probably maybe do one more quick video with this one.